Imagine a solitary traveler drifting through the interstellar void for millions of years, a fragment of ice and dust expelled from a distant system, wandering aimlessly until it encounters our sun. Now imagine that, for the first time, we are able to listen to that traveler. Not through optical telescopes, but through radio antennas detecting a faint signal from the depths of space. This is the story of 3I Atlas, the third interstellar object ever identified, and the first to reveal itself through radio waves. 3I Atlas follows a rare path. It came from far beyond the gravitational influence of our sun. Only two objects like this had been detected before, Oumuamua and 2I Borisov, but 3I Atlas has now become unique among them. In late 2025, astronomers confirmed that the object was moving at nearly 98 kilometers per second, a speed typical of a body shaped by the vast motions of the Milky Way rather than by the sun. But the real surprise came shortly afterward. During a dedicated observation campaign, the MeerKAT radio telescope, located in the deserts of South Africa, detected something unexpected: specific radio absorption lines originating from 3I Atlas. These lines occur at frequencies between 1.665 and 1.667 GHz, associated with the hydroxyl radical, OH, a direct byproduct of water. For the first time ever, humanity recorded radio evidence of water-related chemistry from an interstellar visitor. No encoded message, no artificial modulation, just the natural fingerprint of molecules responding to sunlight as the object heated up. Even so, the significance of this detection is enormous. When an icy body approaches a star, its surface begins to warm. The frozen material sublimates, releasing vapor and dust into space. Among these molecules is hydroxyl, which can absorb and emit radio waves at very specific frequencies. This is precisely what MeerKAT detected. The signal confirms that 3I Atlas contains volatile materials similar to those found in comets within our own solar system, hinting at common chemical threads throughout the galaxy. It is a natural phenomenon, but one with profound scientific importance. For the first time, we can study the chemistry of an object formed around another star without leaving Earth. Astrophysicist Avi Loeb, known for his interest in interstellar objects, commented on the discovery shortly after it was announced. Unlike his controversial suggestions about Oumuamua, Loeb emphasized that the radio signature in this case is entirely natural. Yet he also highlighted how groundbreaking the measurement is. Radio astronomy has reached a point where it can detect the chemical signatures of visitors that may pass by only once in human history. At the time of the detection, 3I Atlas was positioned about 1.8 astronomical units from the Sun, farther out than Earth, but close enough to warm its surface. Its temperature was estimated at around 230 Kelvin, or 43 degrees C. Cold, but not cold enough to keep its water locked in ice. As the Sun's radiation interacted with the object, molecules escaped and produced the radio absorption lines we observed. It's remarkable to think that, from billions of kilometers away, we can detect the subtle radio whisper of water evaporating in space. After passing closest to the Sun, 3I Atlas continued along its outbound trajectory. But before it disappears into the dark once more, another key moment awaits. In March 2026, the object is expected to pass about 53 million kilometers from Jupiter. At that time, NASA's Juno spacecraft will attempt to detect additional radio emissions in the 40-50 MHz range. If it succeeds, it will be the first interstellar radio detection made from a spacecraft, marking yet another milestone in our exploration of the cosmos. The implications of this detection go far beyond the object itself. It opens a new window for studying the chemistry of interstellar bodies, comparing them to comets and asteroids native to our solar system, exploring how water and other life-building materials are distributed throughout the galaxy. Each interstellar visitor carries ancient material, fragments shaped by stars that lived and died long before the Sun ever formed. By listening to these travelers, we learn about places we may never reach. As more powerful instruments come online, such as the Square Kilometre Array (SKA), we will be able to detect even fainter signals from smaller and more distant interstellar objects. Astronomers expect many more such visitors to pass through our solar system in the coming decades. And with each one, new clues will emerge about the formation of planetary systems across the Milky Way. The detection from 3I Atlas is not an isolated event. It is the beginning of an era. For centuries, humanity has observed the universe through light. Now we are beginning to listen to it as well. The radio signal from 3I Atlas is not a message from another civilization, but it is something equally meaningful. A natural voice from an object born around another star, crossing our sky for a brief moment in cosmic time. It reminds us that the galaxy is full of travelers like this, each carrying stories written in ice, rock, and molecules vibrating in radio frequencies. By tuning into these faint signals, we deepen our understanding of where we come from and of the vast cosmic family to which we belong.